Hello and welcome to a new video. Today I will be doing the run through to the Ironman case from Nick Boberg from the round of 32. So in case of the topic, it's a super cool case. I trained with a few good triathletes in the past and also like Jan Frodeno. He is like one of the best triathletes of all time. He trained at the Friendly Club right next to my club. So yeah, kind of coolest thing to see something sportive here and to see triathlon here. But yeah, never mind. Um, the case was quite. It wasn't hard, but it took me longer than I wanted to. So yeah, hopefully in this second run I will be better. No, I don't think that I need here anything else. Probably my Lambda library. Okay. So here this seems to be a 2D lookup. 2DL. Okay. In this table, row is the name, and this is the discipline. And you can track this down. Okay, good. How long does it take in hours? Rounded to two decimals, around 4 kilometers. I think in real life, Iron, and it's like 3.9, 3.4, something like this. X look up for this guy inside here, turning the swimming speed. Wait. Okay. uh, yeah. Uh, okay, track this down. Okay, sorry. I haven't took a look at the numbers. Ah, ah, nah, sorry. Next. Okay, 6.48. Okay, this could be like the world record speed because I think the 150, so 1.5K, 1,500 meters freestyle world record for the men's is 14 minutes and 7 seconds from Florian Welbrock. So short course. I think long course it was beaten by Bobby Fink in Paris, something around 14.5 minutes. So this year is like the world record for 1500 for a full hour or like 45 minutes. That's fast. I don't think that it's appropriate, but open border is kind of different. Oh, sorry for the side. Kick here. So this is kind of annoying because, as always, in my first attempt, I stepped over the instructions. Well, normally you will watch the video first, but here then you will see that here is a different course where you will have different kind of speed levels, and therefore you will have like 6 flat levels, kilometers flat. Here 3, 3, 6, 8 kilometers climb, and then 20 minus 6 minus 8, 6 kilometers descent. And the speed is different, so climbs 0.7 and 0.7 and 1.2 for the descent and 1 for the flat. And therefore, some you will travel slower. Sorry. Yeah. 1 divided by this. and then sorry. So I therefore I will make here a single number to say how much longer you take. So in this case, you will take for the whole leg 1.21 times longer bike leg BL. Okay, and now let's go to this level. X lookup for Bob in here. Returning biking is like the middle leg. Yes, I know this is the speed, and they're biking for 180 kilometers. Ah, 180 kilometers times BL, and then in minutes, so around this times 60 to get minutes, nearest minute. Okay, why? Yeah, of course. Dead errors are costly, but at least in the live format, you see that you scored there next to no points. So yeah. Assuming a start time of 6 a.m., when do they complete the Ironman race? Okay. Was it here? Okay, I think here I started. No, I started only on level 5, but it took me time. So what I did next was building a model for the whole Ironman race, where I took where I calculated at which kilometers the people are at certain points. So here, sequence, I think we have 4 plus 180 plus 42. So kilometer and then discipline. So here, swimming. So normally you will do the best at last, but in this case you're doing the best up front. And then if sequence 180, then biking otherwise. Yeah, didn't need otherwise. And then this is like burning. So, yeah. Okay, this is a discipline. And now, and no, yeah, it's on. Sorry. This one. So, to do this like for the bike legs. Uh, Here, I need here flat for 3, 1, 1, 1. I don't know, probably until there. It should be 20 kilometers. Yes. So 333. Climb is. Could this be right? Here it is. Take model 43 legs. No, only 2. So 3 kilometers. Then going down for 3. Then going up for 1. Then 2 times 1. And then what I should do first is like deleting all the bike stuff to fill this later. Okay, 1, we're here. Then we're going down for 1 and up for 3. And then 1 flat, 2 up, 2 down. Yeah. 1 flat, 2 up, 2 down. And we have 20 kilometers. Now I simply copy this here. Could be done more intelligent. Ah, ah, sorry. Yeah, this is the last one. Everything right so far. So speed quotient, yeah, speed multiplicator. Okay, and then I bring in the max speed of all the competitors. Simply not doing here and lookup or something. Simply copying this in. Ah. Yeah, so swimming speed. Then the biking speed. And also the running speed. 42 columns. And now I can copy this. And now I have the speed for everyone and the legs. So speed per speed. Kilometers an hour, kilometers per hour. And this is right, the right unit. So, and now I did something equals this multiplied with the multiplicator here, and then 1 divided by this to get like the hours they take for that. Like, so here we see Adam, it will take him, so 15, I need to take a look. Okay, no, this is like days. Then divided by 60. Yeah, this is more right. Could this be? No. Sorry. So here multiplication with the quotient, and this is kilometers per hour. And now if I divide, then this is like no. Let me think. Sorry. Kilometers an hour is speed. Now I want to have the time. V equals S divided by T, and then T is V divided by S. And S is 1. And V times S. Doesn't make sense, does it? Yeah, for sure. 1 kilometer takes 0.15 hours. This is super fast. Yeah, but true. Yeah, sorry for that. This was right. And then what I did was scan 0 for the columns here, for the rows here using HRD's lambdas. Sorry. I think I need to make this a name. Okay, and then I have here at which point in time the guys are at the certain kilometer. So here equals 2, 1. Okay, should be right. Now, the start time of 6 a.m. when they complete. So X lookup for Michael in here, returning the last column 11 hours and then 060000 plus this and then text HHMM 23, 23, sorry. Okay, this couldn't be right. 10 hours would be like, yeah, of course. Need to divide this with 60 and 24. No, this is the time in hours as minute in hours as divide this by 24. Yeah, sorry. Only divide this by 24 because then we have like in days this unit, and then we want to round down. No, minutes rounded down. Okay, probably we do something like T. I have here this, and then hour of T and round down minutes. No, minute of T. Yeah, should be right. Minute of T. 1644. It's wrong. Should be 7. Yeah, it should be the same. What's the problem here? Michael Holmes. Is here something wrong? This is repeating. Yeah, for sure. Yes. Okay. I made an error here. I need to divide by this. So here we're getting slower. No, I need to. Sorry. This is like a multiplicator, and my speed is going down here. My speed is going up, right? My speed is going. No, my speed is going down for 2. That's right, and then it's going up. Okay, this was kind of right. 1 divided by. Now it should be fine. Yeah, it is. Need to multiply this with 1. Yeah, and we're good to go. Reference error. Oh, okay, yeah, for sure. Finna 4, finna 4, finna 4. And what could I also do here? Let us check. Use this directly. So text HHMM multiply with 1. No. Yeah, okay. So it's good that we did it that way. So this is kind of not so tricky because I have here my table now with like the positions and times. So after 5 hours, how many kilometers have they traveled? So I will do for this certain person. X lookup for this person. Returning. Oh no. Yeah, right. Okay, X lookup for this person. in here, returning the time. So I have here for every kilometer sequence 4 plus, not this, 4, 4 plus 40 plus 180, 42. So I have here for every kilometer the time the person is ending this kilometer. And then I do an X match for the value 5 hours. Look up here, match mode is 1 and -1. So here the person is at 5 hours between those kilometers, and then index of this array. This is my column number, and here I can now interpolate this. So difference is this minus this. No, this minus 5. And then we are at this plus 1 times this minus this divided by this. And then around this to 1 decimal, and we're good. And then make this data table. I don't know. And then I will do here bad habit, but directly a data table up here. And let's copy this in. Yeah, everything right. Okay, after 7 hours, which competitors are in the following positions for the race? And now I had a problem, because with this interpolating stuff I did here, it wasn't going forward, because like at this, the persons are that tight together that interpolating wasn't doing justice to this example. So Nick Lohman was at position 8 or so in my stuff. So therefore I did it differently. But first I need to make these names better. So I will do this here. Okay, how did I do this? First I created like this match. Was it that match? I don't know. But I can do this. Okay. I need this for every person. Then I need a match for 7, and I need like the start thing here. Yeah. So here, that is the kilometer those persons are after 7 hours of starting, right before 7 hours. Yes. And then I need to build here 24 minutes. Okay, this will take me longer than 30-minute mark. So this is like the start. And now I need to do where they are at that point. Okay, index of or which speed they are at that point. That is, or at the next point. Next point or this point? This point. Okay. Index and at what time they are at that point. Okay. To the L. Okay. I know what to do. Look up to the look up return array is the time they are at this position. Search. I can also do the fast one. To the lookup max. And we want to look for the name and this kilometer here. Okay, they're starting there. Sorry, they're starting there, or Adam is starting there at this time. And the next, or is it the next kilometer? And he is traveling with that I need to do here. This is the speed, so B2, no, it isn't hashtagable. B1, it is, oh, that's great. And then competitor. And then I need to get here another 2D lookup for here the speed at that point. That's unfortunate. Okay. I should have made their gaps. There is a gap. Okay, this is fine. Okay, I can use this. Sorry. To the lookup. This is the speed, and I want to search for Adam and that kilometer. That's a question. Need to think of this. Am I starting or leaving there? So this is my leaving position. So I need here this kilometer plus 1 to get the speed on the next leg. And then, okay, here is our start. And then this is the speed in hours. No speed they need to do the next kilometer. Okay, so 7 minus this, and then this divided by this. No. Well, it's right. Plus this is the kilometer they are, and then I want to have this as a table. 2 plus 1. And Nick is at position 5. And then I can do here an index for those people. Make it fixed. And view row number here. Drag this down. And we have our solution. Now level 7. This is like, this table approach isn't the best, but I haven't had the time to look at the approaches from other competitors. After completing, they're getting tired with different getting tired speeds. Okay, when there is a spell error here. Okay, this will be an A. That's bad. No data table. Okay, this should be enough space. Ah, but this was fixed. Ah, so I let it at where it is. Um, okay, what I want to have here is okay. Let's do this at a different sheet. Okay. This is the first guy. X lookup for the speed because data tables can only handle one input thing. So this is like the depreciation value. Okay, and then I want to have for this guy the speed here. So 2D lookup, no, X lookup for here in my model. And I need to get the right one. This it is. So, not 5. Let's look up for the name. 135. Yeah, there isn't a gap. And returning this. So this is the speeds of the per person. And now we're starting to getting slower at kilometer 100. So sequence 4 plus 180 plus 42 but columns. Okay, and then here it's like this is fine and starting from kilometer. So because this is like the end of the kilometer, we're starting here. So sequence 4 plus 80 plus 42 divided by 20 and round up. This is like 0.9, oh no, 1 plus the percentage here to the power of 1 minus, sorry, 1 minus, so 95, and then going down to this. At 20, this should be right. And then I can do here simple calculate this with this. Right. You're getting, as this is, oh no, this is the time. This is the time, not the speed, right? Yeah, it is the time. So I should do here I should do here 1 plus. So I was right, being wrong. And now we're dealing with the time. And I can do a scan 0 for this sum. And to get the time for those people and what is asked for, hours in 1 decimal, completing, so round index or simple the last cell, and then round to 1 digit, 13.5. 13.5. It's wrong. Okay, that's bad. What should be the answer? 13.6. Okay, so we are close. fine. But what could be the error? Am I starting not soon enough? This could be the case. So here we are, 100. Should be right. Ah. Okay, bring in there Peter and 5%. Fourteen point two, 14.4. Okay, there's something odd. Each 20 kilometers raised. Okay. Starting from 100 kilometers. So here it's getting slower for okay. Okay, yeah, for sure. This is 21 times this. So start with 2, and now we have here this only for 19 times. Okay, yeah, it was right? 90 times, 20 times. This is right. It's going until the end. We are having here the. Oh, why is there an error? This is like the normal speed. This is like the no time, normal time. Time slowed down and running time. So the running total of this. Here everything is the same. Here we're being slower. Is this mathematically the same? So instead of equal 1 divided by this, 1 divided by 1 divided by this. And now this made by 0.95 95. Okay, there is a mismatch here. Yeah, this could be the case. So this isn't. No, I'm wrong. But let's do it. So instead of the time, I want to have the speed. 1 divided by this. So 4.1. Yeah, this looks kind of right. Although the drop is high. Is the drop right? From 32. Yeah, it is. It is. So this multiplied with this, but instead of going up, going down, and then 1 divide by this, and we're having here the right time. So somehow an unfortunate error. Mathematics, the mathematics weren't right. But now it is, they are, and we have our answers. Yeah, so mathematically error. Okay, this isn't an answer. So let's go to the bonus questions. How many kilometers did they complete? So 4 plus 180 plus 1 times 5 multiply with 42 divided by 5. How many kilometers are they climbing, either climbing or descending, not riding flat? So in this case, flat is 6 of 20. So 14 times of 20 times 180. How many competitors are not featured? So they have their list not in list count lambda. But please be careful, I've corrected it because there wasn't error in. So here the large list is the core competitor list. The no. Okay, first I need to do the bonus setup. Um, okay, this is the data I want to search in for. And now list not in list count. The large list is or I can also use your names, competitor, and the list I want to search for is here. 63 is the answer. Disregard the new parameters introduced in 7 who won the race. So what we basically want to have here is this. Is it this? Okay. It's basically this. Can I use this here? Yeah, I can use it. Writing here 0 and putting in there all the competitors. And then making this larger. So now back with sound. Ah, data table. This was the problem. I'm getting old. Data table. Column input cell is here. Min lookup. Lookup here. Return this. Prime handling. Yeah, I tried. Under level 7 rules. Decline 5%. Who will win the race. So here 5%, and we can use this here, and then a simple count if smaller than 12. Yeah, and 76. This is wrong. 77. Yeah, around there. Is it small or equal? Yeah, it's small or equal, but it could be due to the rounding here. So if I do not round there, yeah, it would be 77. Yeah, so for that. So you saw, it took me a little bit longer. Also, I do not know if this like modeling thing was like the right approach to handle it, but yeah, never mind. So at the point where you have this like model, you will be quite fast, but also depending on the mode, the competition mode. Like I think in the live format, this wouldn't be the right one because we have a elimination right live format. So yeah, you never know. So thank you for your attention. I hope to see you in the next video and in Vegas. Bye.